In a previous video, I talked about the choice of either up being the positive direction or down being the positive direction. I wanted to follow up on that choice about up being positive or down being positive. Again, thinking about the problem of dropping an object from the roof of a building to the floor below, and the choice of where you call the coordinate origin. You could call the coordinate origin the floor. You could call the coordinate origin the roof. And again, that's a choice that you make. That's your choice you're making when you solve the problem. And you can find the time for the object to fall, having made the choice that the ground is the coordinate origin, or having made the choice that the roof is the coordinate origin. And as long as you stick with that choice, you're consistent with that choice, you'll get the correct time for the object to fall from the rooftop to the ground below. So let's take a look at that example. So in this problem, I went to the top of Patterson Office Tower. It's a 50-meter high building, and I dropped an egg from the top of Patterson Office Tower to the floor below. And we're going to figure the time that it takes for the egg to reach the ground below. And we're going to do it with these two possible choices. I can choose the coordinate origin for the vertical motion to be on the ground. I can choose the coordinate origin for the vertical motion to be on the roof. And we're just going to follow through the calculation with those two alternative choices and see that we get the same result for our calculation. So let me start with a sketch over here on the left. Here's the falling egg. The egg is released from rest, initial speed 0, and it accelerates downwards at minus 9.8 meters per second squared, the acceleration of gravity in a downwards direction. In this case, I'm calling the ground the origin. So the final location of the egg is at the origin, and the initial location of the egg, y0, that's going to be 50 meters. That's the rooftop of the building. Now, look carefully about how I wrote down these numbers. So I have made two choices here. I've made the choice that upwards is the positive direction. That's one choice. And I've made the choice that the ground is the coordinate origin. And I've written down the positions, velocities, accelerations consistent with that choice of up being the positive direction and the ground being the coordinate origin. So the rooftop height is positive 50 meters. The acceleration of gravity is negative 9.8 meters per second squared. So now we'll go ahead and solve the problem. We use the kinematical equations, the equations of motion. And the one that works here is the following equation that involves the initial, final positions of the egg, the initial speed, the acceleration of the egg, and the quantity that we want to solve for, the time taken. And this is easy to rearrange because the initial velocity is 0, and all we have to do is multiply through by 2, divide through by the acceleration, take the square root. If you do that, we get this famous equation for the time it takes an object to fall in terms of the displacement and the acceleration. And we can just fill in the numbers here. So 2 times the final position less the initial position, so that's 0 meters minus 50 meters, divided by the acceleration, minus 9.8 meters per second squared. Inside the square root, we got minus 100 meters divided by minus 9.8 meters per second squared. That comes out to be 10.2 seconds squared. And we just got to take the square root of that. That's 3.2 seconds. And so that's our answer based on this choice that we made at the beginning as we set up the problem of the ground being the origin and upwards being the positive direction. And let's compare the calculation with the second choice about the coordinate origin. That the coordinate origin is going to be the roof of the building. So again, I start with a sketch, and here's the falling egg. And I start to annotate the sketch with the things I know. Initial velocity, I release the egg from rest, and it falls downwards in the negative direction with an acceleration of 9.8 meters per second squared. Now this time, I'm going to call the rooftop the origin, so y0 equals 0, and then y, the final location, the ground, will be minus 50 meters. If the rooftop is the origin and we've chosen upwards to be the positive direction, then the egg is moving in the negative direction and its final coordinate will be negative rather than positive. So it'll be minus 50 meters here. Well, this is the quantities for this problem with my choice that upwards is positive and that the rooftop is the coordinate origin. And now we can go ahead and solve the problem. We would use the same equation of motion, kinematical equation. I won't write that down again. We would rearrange it in the same way. I won't write that down again. And then we would just fill in the numbers for the initial, final locations and the acceleration as we did in the previous case. So it'll be 2 times the final position minus the initial position in the numerator divided by the acceleration, 9.8 meters per second squared in the denominator. And again, we end up with, in the numerator, minus 100 meters divided by minus 9.8 meters per second squared in the denominator. That gives us, again, positive 10.2 seconds squared, and we just take the square root of that to get the time. We get positive 3.2 seconds. And so you see there that the choice of the coordinate origin, whether it's the rooftop of the building or whether it's the ground below, does not affect our answer to a calculation of the time taken for the egg to hit the ground. It's just a choice that we made in solving and working out the problem. In fact, we could have chosen anywhere to be the coordinate origin. I could have chosen the center of the Earth to be the coordinate origin and wrote down y and y0 based on that choice. It wouldn't be very convenient. I could have chose the 3rd floor of the 50-meter high building to be the coordinate origin and wrote down y and y0 with that choice of coordinate origin. Again, it wouldn't be so convenient. I could have chosen the moon to be the coordinate origin and written down y and y0 with that choice that the moon is the coordinate origin. Again, it wouldn't be very convenient. But all of those choices, choosing the origin to be the ground, the floor, the Earth center, the moon center, the 3rd floor of the building, they would all yield they would all give the same result for the time that it takes for the egg from leaving my hand to hit the ground. So that's one more example of a choice that you make when solving a problem. Sometimes I think we don't like choices when we solve problems, but we do have to make choices when we solve problems. And what we have to do is be consistent with those choices we